Hello students, today we are going to do section 3 of chapter 4. Now we're going to talk about Bohr's model of the atom. Bohr agreed with Rutherford in the fact that there is a nucleus. He put electrons rotating around the nucleus in energy levels, and energy levels are just possible energies that electrons can have in an atom. Here's a picture of Bohr's model. Bohr's model has the nucleus still with the protons and the neutrons, and then the electrons are in those energy levels. You see 2 electrons in the first, 4 in the second for this carbon atom, and those electrons are able to rotate around the nucleus. So the electron cloud was just where all the electrons are, and then, as I said, the electrons are in levels for Bohr's model. In the first level, it can hold at most 2 electrons. It can have less than 2 electrons, but it can't have more. The second level can hold at most 8 electrons. The third level can hold 18 electrons, and the fourth level can hold at most 32 electrons. Electrons must be placed in the lowest level possible. They have to be in the lowest level possible. And the outermost energy level of any atom can only hold 8 electrons. Energy levels. The electrons, like I said, rotate around the nucleus in the various levels. The higher the energy level, the more energy it has. So higher energy levels contain more energy, while lower energy levels contain less energy. And electrons have to gain energy to move up a level, and they lose energy to go to a lower level. You'll see this in a lab where we will give its electrons some energy by heating it, and it will move up a level, and then when it goes down a level, it will release that energy in the form of light. Stable electron arrangements. We'll talk about that in this chapter as well as in chapter 6. Stable electron arrangements are atoms with a full outer shell energy level. Usually 8 electrons are considered to be stable. Stable atoms generally do not react anymore. Energies and groups. Groups are going to be your vertical columns on the periodic table. The group number is equal to the number of outer shell electrons. And the periods are your horizontal rows. The period number is equal to your number of energy levels. Phosphorus, 31. Remember, we're going to draw atomic diagrams for the next 2 slides. Now, I want you to remember that this right here, this right here is the mass number. So the first thing I always suggest you doing is writing down 10. So P is for protons, E is for electrons, and N is for your neutrons. Looking at the periodic table, you'll want to find phosphorus, which is right here. And you want to look at the atomic number, which is 15. So that will tell you your protons and your electrons. To find the neutrons, you want to take the mass number, 31, minus your 15 protons to get 16. Now, if you remember from the section 2 notes, I told you that there are the protons and the neutrons go in the nucleus. So we're going to start with 15 protons and 16 neutrons in the nucleus. Then we're going to draw our first energy level that has electrons in it. On a few slides ago, I told you that 2 electrons can go in the first energy level. Next, we need to get up to 15, so we need to draw more energy levels. So our next energy level can hold up to 8 electrons. So since we need to get to 15, we'll add 8 because now that gives us 10. We're going to draw another energy level because we're not up to 15 yet. Our third energy level can hold 18 electrons. However, we don't need 18 electrons. We have 10 already. 2 plus 8 is 10. We need to get to 15, so we only need 5 more electrons. So we've got 2 plus 8 plus 5 is 15 electrons. Let's try one more. Oxygen 17, you should pause and try to do this on your own. Remember, I always start with the pen. If you look for oxygen on your periodic table, oxygen's right here. Its atomic number is 8. So it will have 8 protons and 8 electrons. The neutrons, to find the neutrons, you would take the 17 minus the 8 to get 9. You always start with the nucleus, so the 8 protons and the 9 neutrons go in the nucleus. Now we need to get to 8 electrons. We're going to put 2 in our first energy level because we can have only 2. Our second energy level can hold up to 8, but we don't need 8 because if we put 8 in there, we would get 10. We only need to get to 8 electrons, so we're going to put in 6 electrons because 6 plus 2 is 8. One more thing you need to know for this is to figure out how many outer shell electrons would calcium have, or any other atom, and how many energy levels it would have. So I told you a few slides ago that the outer shell electrons are equal to the group number. The energy levels are equal to your period number. Now we haven't gone through group number and period numbers, so you can take out your periodic table and fill this in if you would like. The period numbers are already given to you. Those are right there. Those are your period number. Your group numbers are going to be on the bottom. For your periodic table, it says group number and valence electrons down here. So we're going to fill in the group number and valence electrons. We've got group number 1 and 2. And then over here we've got group 3, 4, 5, 6, 7, and 8. So if you go to calcium, it said you want to know how many outer shell electrons, which is the group number. So calcium is right here. It is in group 2. So it would have 2 outer shell electrons. How many energy levels would calcium have? Calcium is here. You go over, and it is in period 4. So it would have 4 energy levels. To see that with another element, you can do that with oxygen as well. So there was our oxygen. I'm going to add the group numbers down below so we can see it. If you look at your diagram, if you want to know how many outer shell electrons it has, you look at the group number. The group number is 6. If you look at the diagram we made, it has 6 outer shell electrons. If you want to know how many energy levels it has, you go to the period number, and that's 2. And it has 1, 2 energy levels. So it does show you how the diagram should look. That is it for today's notes. Have a good night.